Okay, so hello guys. For this discussion video, we will have more of the examples on the fundamental trigonometric identities or trigonometric functions. So we will begin an examination of the fundamental trigonometric identities, including how we can verify and how we can use them to simplify trigonometric expressions. So when we talk about identities, this identities enables us to simplify complicated expressions. They are the basic tools of your trigonometry used in the solving of trigonometric equations, just as factoring, finding common denominators, and even using special formulas are the basic tools of solving equations. So in fact, we use algebraic techniques constantly to simplify trigonometric expressions. Basic properties and formulas of algebra, such as the difference of squares and the perfect square formula, will simplify all the work involved if we have to consider trigonometric identities or simplification of trigonometric functions. Okay, so we already know a lot of concepts in the field of geometry, and in the field of trigonometry we have our introduction video on this field wherein we or in this topic, which could definitely propel and help you in the success of these topics. So to verify certain trigonometric identities, we usually start with the more complicated side of the equation and essentially rewrite sang sinaang expression until it has been transformed into the same nga expression as the other side of the equation. Sometimes, we have to factor expression, pwede man expand expression, find common denominators, or pwede kita makagamit sa mga algebraic strategies naton to obtain sa aton nga desired nga result. So, if we have to consider sa aton nga trigonometric function, first kinahanglan naton i-master is the Pythagorean identities. So we have here, so Pythagorean identities are the Pythagorean identities, which are the equations involving sa aton nga mga trigonometric functions based on the properties of your right triangle. So we have already presented this sa previous nga discussion video. But for this one, I have here trigonometric nga identities based on Pythagorean nga relationship. So we have sine squared theta plus cosine squared theta is equal to 1. 1 plus cotangent squared theta is equal to cosecant squared theta. And 1 plus tangent squared theta is equal to secant squared theta. So, okay, so actually, if we are just aware of this first function or this identity, sine squared theta plus cosine squared theta is equal to 1, pwede ta na gani malanta or pwede ta na makuha ang iba ni nga mga type of identity. So, sige, let me just present it to you kay para mangin aware ka mo kung sa diin na siya naghalin. So, we have this one. Okay. Okay. Okay, so ang natabo lang man for this one, para makuha mo nga value. So, we have sine squared theta plus cosine squared theta is equal to 1. So, divide siya naton. Kabilugan nga equation, divide ta siya by sine squared theta. So, sine squared theta. Okay, sine squared theta divided by sine squared theta, this is equal to 1. Okay, so cosine all over sine, this is cotangent. So this is cotangent squared theta. This one, 1 over sine, this is cosecant squared theta. That's why we have this equation, 1 plus cotangent squared is equals to cosecant squared. So, dra lang mo na siya naghalin. And if you will have to find or to derive this formula, ang himuon mo naman is you have to divide all of the equations by sine. So, ang natabo is we will have sine squared theta plus cosine squared theta is equal to 1. Ang i-divide na naman sa buong is cosine. So, divide siya by cosine squared theta. Divide mo siya by cosine squared theta. Then, we have cosine squared theta. This one, ari is tangent. So, this is tangent squared theta. This is 1. This is secant squared theta. So, dali na naghalin ang aton nga Pythagorean identities. Okay, so let me give you another example of proving sa aton nga identities. For example, you are given an equation 1 plus cotangent squared, okay, cotangent squared theta is equal to cosecant squared theta. Okay, kung ang question is, you have to prove kung ang ining equation is ang hambal is prove ang ining equation 1 plus cotangent squared theta is equals to cosecant squared theta. Then what we have to do is to pangitaon naton kung diin ang medyo komplikado nga part and dra kita ma-start. So that means we have to rewrite sang sininga part of the equation. We have 1 plus, wait lang. Okay. So we have 1 plus cotangent squared. So bot silingon, this is equal to, so 1 plus cotangent squared theta, this is, since cotangent, that is cosine squared, okay, theta, all over sine squared theta. This is equal to cosecant squared theta dapat. So aton nga goal is dapat mahimo ta siya cosecant squared theta. Next, so we have, so kung i-perform naton ang aton nga kung kwaon naton himuon siya naton isa lang ka equation, so this will be, so we will have your sine squared theta, wait lang, okay, so we have, this will be sine squared divided by 1 is sine squared times 1, that is sine squared theta, plus, so your cosine squared theta. So nagginkuha ko lang ang common denominator ang aton ni LCD. This is equal to cosecant squared theta. Take note, dali lang kita ma-manipulate, dapat aton answer maging parehas ini. So we will have, so sine squared theta plus cosine squared theta, based sa aton kaginang identities, so sine squared plus cosine squared is equal to 1. So that means we will have 1 all over sine squared theta is equal to cosecant squared theta. Okay, 1 all over sine squared theta, ano ni siya? This is cosecant squared theta. Okay, is equal to cosecant squared theta. Since this is correct, therefore, na-prove nato ng ini nga identity. Okay, so sige. So, i-prove naton ang another nga identity or ang another diri nga equation which is 1 plus tangent squared theta. Okay. 1 plus tangent squared theta is equal to secant squared theta. Okay, so that means dali kita ma-manipulate kaya mo ni ang mas complex nga part 1 plus tangent squared, so we will have 1 plus sine squared theta all over cosine squared theta is equal to, dapat aton answer dapat karon secant squared theta. Take note, hambal ko gani isa-isa ka discussion video naton, mas okay if we have to transform an equation into its sine and cosine equivalent. Kay medyo hapos sa aton ang sine and cosine, kag medyo familiar kita sina nga type of equations. So we have sine squared theta. Ang tangent, i-convert siya into its sine cosine equivalent. So same man Japon, we have to find our common denominator. So we have cosine squared theta. Okay. So ano ang i-divide mo sa cosine squared? Nga ang answer natin 1. So syempre cosine squared man Japon. Plus So we will have sine squared theta, copy ko lang na, is equal to your secant squared theta. Okay, so ang natabo, digin pangita natin ang aton nga LCD or ang aton nga common denominator. So we will have, this is equal to 1 ang sa babaw. So we have 1 all over cosine squared theta is equal, dapat aton answer sa secant squared theta. So 1 over cosine squared, this is secant squared theta. Okay, is equal to secant squared theta. So since this is equal, that means na-prove nato ang aton nga identity. Okay, so another equation nga or another type of identity nga pwede naton ma-encounter is your even odd identity. Pwede nga ma-encounter niyo ni. You have also your reciprocal identities. Take note lang kung anong kakatabo with your even odd identities. So just consider this one. For tangent, it will be negative tangent. So tangent, kung negative ang angle, equal siya sa negative tangent theta. Cotangent of negative nga angle is negative cotangent theta. Sine of negative angle is negative sine theta. Cosecant of negative nga angle is negative cosecant theta. Cosine sang negative, positive na siya. Secant sang negative, positive na siya. So, ang naglain lang dari sa tanan is your cosine and secant. Positive sila. So, positive lang nga answer. Okay, so for reciprocal identities, this one was mentioned man sa previous natin nga discussion video. Reciprocal identities, this is, ang sine is tuli niya is cosecant, ang iyang reciprocal I mean is cosecant, cosine is secant, tangent is cotangent, and vice versa. So, we have also your quotient identities. So, quotient identities, that means amo na gamit na naton kagina, tangent is equals to sine over cosine, cotangent is equals to cosine over sine. Okay, so amo na siya ang aton nga mga kinahanglan i-master nga identities. So paano naton or anong pwede naton himuon if we will have to consider sang mga calculation naton regarding trigonometric identities. So number 1, given a trigonometric identity and you will have to verify if it is true. Ang pinagid para sa ginhimo naton kagina is to work on one side of the equation. Okay, so it is usually better to start with the more complicated or more complex nga side, and it is easier to simplify them than nga ikaw ang maubra sang equation. Masapos nga i-simplify mo sila. So look for opportunities wherein pwede kita maka-factor sa mga expressions and pwede kita maka-square sang binomial o pwede kita maka-add fractions. So just look for that possible opportunities. So noting which functions are in the final expression, look for possible nga makita ni mga opportunities to use the identity and make the proper nga substitution. So, tanaw nimo anong imo nga goal. Diin ka dapat pakadto ang imo nga answer. So, if these steps do not yield the desired result nga expected naton, so pwede nga we could try converting all terms to sine and cosine always. So, as much as possible, kung pwede lang mo siya ma-convert into sine and cosine, convert siya naton. Kay it would make it easier to manipulate. Okay, so we will have, sige, so I'll be presenting some more nga example nga pwede ninyo mangin basihan for the calculation. Okay, para, okay, so we have here, so sige, mangita ta. So we will have, okay, so for example, we are given tangent theta. We have cosine theta is equal to sine theta. So, muna ang given sa ating equation. And we have to verify this trigonometric identity. So, ano pwede natin himuon? Hambal naton kagina, start with the complicated one or the complex part of the equation. Di nang mas complex. So, ari ang mas complex sa ating left side of the equation. Therefore, dapat aton nga goal is, aton answer karon is sine theta. Okay, so para hindi ka mo ma-confuse, hindi ko ni paghilabtan o hindi ko pagkapihon ang sine theta. That means, so diri lang ko danay manipulate. So anong pwede natin diri ma-manipulate? Hindi ta na manipulate ang cosine kay cosine na siya daan. So let's manipulate the tangent nga side. Based on the quotient kaginang identity, tangent is sine theta over cosine theta. Then I have, copy ko ang cosine theta. So, cosine theta. So, sine theta all over cosine theta. So, pwede na ito makancel ang cosine theta. Ang nabilin dari is sine theta. So, and take note, equal siya sa itong right side of the equation. This is correct. Okay, the identity is fairly simple. Hapos lang siya i-verify. So, again, ang pinakahapos nga way is to convert it into its sine and cosine equivalent. Okay, so what if given sa aton is 1 plus sine x multiplied by 1 plus sine, then we have negative x is equal to cosine squared x. So, muna ang given sa aton equation. And what we have to do is to verify this equation or this identity. So, that means, hambal naton, we have to start with the complicated part or the complex part of the equation. So, diri kita ma-start. Muna ang complex na part. So, we have, so, take note, bisan ano pa himuon naton diri aran siya sa simplified part kay sign na lang siya and wala man kita naka-squared, wala man sa naka-fraction. So probably ang pinakahapos diri nga method nga pwede natin gamiton is the even add identity. So even add identity. So we have here. So since we have a sign of your negative na angle, pangitaon ta anong equivalence na. Sign of your negative theta is negative sine theta. So we have, okay. So, ang equivalent ng sine negative theta is, ang equivalent sini is negative sine x or negative sine theta kung theta ang given. So, negative sine x. Therefore, gali, this is equal to 1 plus sine x multiplied by 1 minus sine x is equal to amo ni dapat aton answer karon. So we will have this one. So since this is a binomial, so binomial sila, and then we have kung i-perform naton ang algebraic operation here. So this is difference of square. So since parehas sila nga first term, parehas man ila second term, lainanay lang sila function. That means square mo ang first, square mo lang man ang second. So we have square sang 1 is 1 minus, so sine squared x. So this is our equation now. Pwede man kung gusto nyo yung mag-perform sang FOIL method, pwede man Japon. You will come up with the same answer, 1 minus sine squared x. So based on the equation, take note, we are given cos, okay. Okay, so we have sine squared. Take note lang nga theta plus cosine squared theta is equal to 1. Amo ni diba ito niya ginabasihan. And we have 1 minus sine squared. Ano na siya? 1, silinon ko to ang sine squared. So this is minus na. 1 minus sine squared theta. This is equal to cosine squared theta. That means ang bilog ng equation is equal to your cosine squared theta. And this is equal to cosine squared theta or cosine squared x, I mean, sa right side sa aton nga equation. And this is verified nga identity. Okay. So, amo na. So, amo na ang pwede naton i-perform nga operations. So next we have, so I'll be giving another type or another example. So we will have this one. Okay. Okay. So verify the identity. We have secant squared theta minus 1 all over your secant squared theta is equal to sine squared theta. Okay, so we have this equation. So we have to start with the complicated parts sa aton nga equation. So we have second squared, may ara kita second squared sa aton nga equation. So we have second squared is equal to yung second squared is 1 plus tangent squared. Sige, 1 plus tangent squared. So substitute natin siya with your tangent squared plus 1. So this is tangent squared theta plus 1, then minus 1 all over second squared theta is equal to, amo ni dapat later on ang aton nga mangin answer. Sige. So we have okay. So ang 1 kag ang minus 1 makancel ni. So ang mabili na lang sa babaw is your tangent squared theta, then all over your second squared theta. Okay. So tangent is sine. Okay. Dari na lang ko masudpon. So you will have your tangent is sine squared theta all over cosine squared theta. Next, second. Ano naman niya ang identity for second in terms of sine and cosine? Second is, okay, so this is all over. I-read ko lang kay para hindi ta magtalang. So we will have second squared is 1 all over cosine squared theta. So this is, so that means if i-divide ko na sila, I have to reciprocate or to find the reciprocal of our denominator and proceed to your multiplication. So this is sine squared theta all over cosine squared theta multiplied by, so liong ko ni, this is cosine squared theta all over 1. So this is equal to, makancel ni, mabili na lang is sine squared theta. So this is sine squared theta. Okay, so check ta kung, so this is correct, sine squared theta. Okay, so mo naton nga equation. Okay, so pwede bisan ano nga type of trigonometric identity ang pwede nimo gamiton. So may ara man pwede ka man ka perform sa trigonometric identities like, so sige, we have, so second squared theta minus 1 all over second squared theta. So mo ni, dapat imo answer is sine squared theta. Okay, so isa-isahon ko ni, this will be second squared theta all over second squared theta minus 1 all over second squared theta. Gin-separate ko sila dua. Since parehas lang man sila, denominator. So we have second squared plus second squared, ano ni? This is equal to 1. So 1 over second squared, this is cosine squared theta. So that means this is 1 minus cosine squared theta. Ano ni ang 1 minus cosine squared theta? So based on your trigonometric identities, this is sine squared theta. So which is equal to the right side sa aton nga identity. Okay, so this is it, Danay, for this discussion video on your basic trigonometric identity nga verification. So this is it for now. Thank you. Stay safe. God bless.